Guys, I'm going to go over the review, and yeah. So number 1 is 2x squared y to the 5th power over 7x cubed yz times 14xyz squared 18x4y. So when you multiply, obviously you just multiply across, but to just make things easier, we're going to cancel things out before we start multiplying. So this x squared and x cancel out x cubed. 14 and 17 cancel out each other, 18 and 2 as well. And then 1y can cancel, and then there's another y that cancels, and then z cancels out like this. So in the end, I have 2 as a number from 14. There's no x on top. There is 4 y's because there's y cubed here, but there's another y here, and then another z left. In the bottom, there is 9 and x to the 4th power, and that's all it is. Number 2 is division. So the first thing you need to do with division is you need to flip the second part, the divisor. So I'm going to do that. So we multiply and flip. So 7a squared c goes on top, and 12abc goes on the bottom. So again, we can start by canceling things out. There's 2a's, can cancel out with a squared. B cubed can cancel out, and then another b cancels out, and then c cancel out c. So then the number wise is 2 on top, a to the 4th power, b squared over, there's 5 here, and that's all I see. Let's go to number 3. Number 3 is a multiplication, but you have to factor in this case. So I'm going to rewrite the problem as I factor. So the first one, I'm just factoring out GCF. And then the bottom, it's basically factoring the trinomial. There's a GCF again. And then another GCF here. So let's cancel. 6 and 3 cancels out, and 2 and 4 cancels out. X plus 2 cancels out with x plus 2. And x minus 1 cancels out with x minus 1. So then on top, only 2 is left. And the bottom is x plus 3. Number 4. Again, it needs a factoring, so I'm going to factor as I rewrite this question. And then this one is division. So we are going to change multiplication and the reciprocal. So then, now that we have everything factored out, we can cancel. And in this case, this is all you can do. But 3 gets canceled as well. So then on top, n plus 2, and then plus 5. And you don't have to FOIL them again. I'm just happy with what you have there. Okay. Alright, 5. R squared plus 3r over r plus 1. And 3r plus 3. With the complex fraction, I'm going to show you one way you can do, which is applying the division. So let me rewrite them in terms of factor. So it's basically this fraction divided by the fraction in the bottom, right? So then we can apply the same thing that we did. And then change this to multiplication, and then rewrite the fraction in the other way. So these things cancel, and then in the end, it's just r plus 3. For number 6, I'm going to show you solving it just from the complex fraction. So I'm going to factor first. Please don't forget about the a squared minus b squared factoring. And why I keep emphasizing it, it's because it's that important. Okay. If you want to just deal with the complex fraction the way it is written, you need to realize that the denominators can cancel each other. Okay. And there is no more to cancel. And then when you write the actual fraction, you multiply the insides together, and then they become your new denominator. And then when you multiply the outsides together, and then it becomes your numerator. Okay, and that's it for the number 6. Number 7. So number 7, it says r cannot be plus minus 2. And you need to know this because there will be a question that asks you to find what restriction does your rational function have. And the reason r cannot be plus minus 2 is because when you factor this out, it's r plus 2 and r minus 2. So obviously, you can't have minus 2 or positive 2 as your domain, because that will make the denominator 0, and we can't have that. So then once the r plus 2 cancel each other, the answer is B, right? 8. Identify all values of x of which it's undefined. So when you are looking at whether the function is undefined, we only look at the denominator. So I'm going to factor the denominator a little bit further because the trinomial can be factored this way. So x minus 9 times x plus 3 is the same thing as x squared minus 6x minus 27, and there's x plus 1. So if these things equal 0, then the function is undefined, right? So basically I need to set x minus 9 equals 0, x plus 3 equals 0, x plus 1 equals 0. So x cannot be 9, negative 3, or negative 1. So that answer is H. 9. It's asking for LCM. So when you do LCM, you need to make sure you factor first, right? Alright, so this has x and x minus 1. And this one, once you factor, it's this, right? But x minus 1 and 1 minus x is similar. It's just that 1 minus x has been multiplied by negative 1. So what you can do is that you can factor out negative 1 and then rewrite the second one as x minus 1. And the reason I prefer you do it this way is because then you wouldn't get confused about x minus 1 and 1 minus x being essentially the same, okay? So then we write everything that you see once and then compare the power. And this is it, because the highest power for everything is 1. That trick is actually very handy, so I want you to get used to that trick, okay? Factoring out negative 1. Alright, this one is a simplify, so you need to first find the LCM of each denominator. But before I do that, I always try to factor as much as simplify as much as possible. So for example, this 2 cancels, and then 1x's cancel, and then x's cancel each other. So I can essentially write this as 2xy and then 1 over 3y cubed. So then I need to find the LCM, and LCM would be 2 times 3 times x times y cubed, right? Because y has the highest power is that. So then the first fraction still needs 3 and y squared, and then the second fraction is missing 2 and x. So my answer is 3y squared plus 2x over 6xy cubed. Even if you don't start by simplifying your fractions in the beginning, after you solve everything and you simplify, you will get the same answer. Okay. 3, 4m plus 2, 3mn squared minus 4. And okay, so then the the common denominator will be 4 times 3, because I'm doing the number first. I see m and I see n, and the highest power of n is 2. So I'm going to put 2 in there. So then we need to think about what do we need to multiply in the first fraction to make it look like the denominator. Well, it already had 3, and I'm missing 3 and n squared, right? And then the second one, I already had 2, but it's missing 4, and it has m, it has n squared, and so 4 is the only thing that is missing. And then the last one, it had 4, but then it's missing a lot of stuff, right? It's missing 4. So guys, do you see I'm looking at only the denominator? It doesn't matter what the numerator already had. It doesn't matter. I'm only looking at the denominator and what it's missing. It's missing all the numbers and m and 1n because it's a n squared and I only had n in my fraction. So let me simplify this. 9n squared plus 8 minus, this is 12 times 4, 48 mn. And then the bottom is 12mn squared, and that is the simplest form of this fraction. All right, 12. 6 over, I'm going to just factor as I see because I need to factor anyways. And then minus r minus, sorry, 3, r minus 2. So then my new fraction has a r minus 6, r plus 3, and r minus 2 as the denominator. And then if you look at the first fraction, it has 6 already, but it was missing r minus 2, so I put it there. And then minus, because it was minus, it had just 1, so I don't have to write that again, but it's missing r minus 6. So when I simplify everything, it's 6r minus 12 minus r plus 6 over those three factors multiplied together. You don't have to FOIL. So then the answer after I simplify everything is 5r minus 6 over r minus 6, r plus 3, and r minus 2. All right, let's look at 13. 13, I'm going to again factor as I rewrite my stuff. Okay, so this is where you see common factor of -1, right? And the reason I do that is because it's a lot easier if I already have a same denominator, and it does. And you'd be wondering, what do I do with this negative sign? I can actually think of this as positive and make 6 negative. The reason I do that is because it's a lot easier to deal with it this way than try to multiply the first fraction by -1. So the answer is simply 3x over x plus y. So so the negative number manipulation is actually a key to get better at more complicated manipulation with algebra. So this one is x minus 4, x plus 1, plus x plus 1, and 2, x minus 4. So I'm not going to cancel anything, even though this one can be canceled, because, let me start by canceling, okay? Even though it doesn't make much difference, I still have, but maybe it will simplify things. So you can see from the fraction, it's missing 2 and x minus 4 because I canceled out x minus 4. And then from here, it's missing x plus 1, and it already had an x plus 1. So if I quickly simplify this, it's 2x minus 8 plus x squared plus 2x plus 2 over the denominator. I'm running out of time, so I'm just going to write the numerator again. And this is the numerator, and the denominator stays the same. And that's it.